Da-da-da-da-dum. I should be live now. What's up, YouTube? Going live right now, just working on some things. I've been working on this for the past couple of weeks, but, or not this, but I've been working with StyleTTS for the past couple of weeks, and I've gotten a hang of it and a feel for how things work and whatnot, so decided that I would just package it up and, do the same thing that I did to Tortoise TTS and release it as a downloadable Windows package. So I've actually already got the downloadable package sort of part down. There is, I think you need to be matching CUDA versions for NVIDIA. And so I'm on my GitHub page right here. This is just me cloning the StyleTTS2 into a fork. But let me go ahead and show my VS Code real quick. Alrighty. Already. So here we go. We have StyleTTS2, and what I can do here is just run a quick little inference script, and it's going to it's going to do inference on the model that I trained, and it's going to output a sentence. So it's very rudimentary right now. It's very just it's mainly just a Python script. I don't really have anything abstracted into functions or anything like that, so I'll have to do some refactoring to turn it into a graphical user interface. But as you can see, it just finished up here, and we can play an audio snippet. So let me actually just mute my music real quick and just show how the inference sounds. And this is the sentence that that I am inferencing on. My name is Melina. Have you heard of the Finger Maidens from Elden Ring? And here we go.
My name is Melina. Have you heard of the Finger Maidens?
So that's StyleTTS2. It's pretty good. And it's very fast. It's much faster than Tortoise TTS, which is why I want to work with Tortoise TTS. StyleTTS. And yeah, it's fast, it's predictable, and it sounds good. Now, Tortoise TTS does sound better than StyleTTS2. However, it's definitely not as stable. And so if you want stability, something like StyleTTS2 is going to be the way to go. And with that, I'm going to start doing my coding things. So, yeah, let's see. Alrighty. First steps first is I kind of have everything on my computer in its own little isolated area, but I want to put everything up onto GitHub so that I can start what is it? So I can make sure that I have version control, and my process and progress is saved. So that is where I have this StyleTTS2 interface, this GUI right here, not interface, GUI, GitHub page. And what I need to do is clone this repository, and then I'm going to push all of my updates to it. So to do that, I am going to navigate to where I want to inside of the terminal here. I'm going to cd out my packages folder, and then I'm just going to git clone this repository into there. Alrighty, and so also you guys can see. And so it's currently cloning StyleTTS2 right now. And it's a relatively hefty GitHub repository because it's got some models inside of it already. But yeah, 133 gigs, 133 megabytes. So that is cloned, and what I now need to do is just copy and paste some of the files, or basically I need to copy and paste all of the files that I have inside of this modified repository into that GitHub repo. So you guys won't be able to see it, but I'm currently working off screen so that I can do all of that copying stuff. And yeah, this will take a little bit of time. So if you have any questions, just feel free to throw or lob a comment, and I'll answer as I go. But yeah, usually I do this because I want to make sure. Well, first, what I did is I made the package first just to test out StyleTTS2 on Windows, and then once I have that, then I would confirm that everything is good to go, and then do all the GitHub stuff after I've tested that things work. Alrighty, let's see. Package, StyleTTS, modules. Models. Oof, that's a big copy. So currently still doing some of the copying from one folder to the next. Models, pre-trained base. Okay, I think I have everything in here that I need actually. So now what I can do is open this modified repository into VS Code, and then you guys can actually see what I'm doing. So let's see what is up here. Alright, so here we go. Let's go here. And then we'll do git status just to check our status. And we've got all these different modifications. So let me just make sure that all these modifications are what needs to be added. I can delete this, delete test.py, run fine tune that, inference script, download punct. Models. Okay, and then inside of models, I can actually add a file. What I need to do is add a git ignore file into here, put it one directory up, say ignore everything. Hold on, let me. I haven't done this in a while, so I got to make sure that that's the correct way to ignore everything. Alright, here we go. This is the correct way to do it. Alright, ignore everything, and then do not ignore .git ignore. Alrighty. So, let's get status again. Okay, punct, inference script, fine tune, modules. Excuse me. Okay, this looks good. So let me add everything. Oh, what is this? LF will be replaced by CRLF. I don't know what this means actually. What is this? Okay, so just to match formats, I guess. Oh, it's nothing too big. So let me go back and get status, make sure we got everything. Okay, new file, git ignore, modules, this. New file, inference script, losses, fine tune, bats, train accelerate. Oh, is that really everything? Modules? Git status? Alright, I think that is everything. Git commit, add modifications to GitHub repo, git push. Alrighty. Cool. So that has been done. Now let's take a look at the GitHub page and make sure the changes have been executed. So modules, all the things that need modification. Okay. Models folder got added. Cool. Yeah, it looks like we got all the GitHub stuff that we needed to be done there. Let's go back into VS Code. Yeah, here we go. And now we got to start doing some refactoring. So this is going to be the biggest time sink because I just need to put all these things into a Gradio Interface, and yeah, it's just gonna take time to build. So where to start first? Hey guys, welcome to the stream. Random person 07. Am I going to release this? Yes, I am going to release this when I finish, but it's probably not going to be done today. Just kind of laying out the framework and laying out the process for how I'm going to go about doing this. What's up, Valley View? Thank you for tuning in. Hello, how are you? Alrighty, so what I usually like to do when I make Gradio interfaces is start from where I know something works, and then move, and then build component by component, just testing out, and making sure that certain function calls work as they should. So I would need to set up my environment here with venv. However, what I will just use is I have this runtime package that I packaged up in order for it to work on Windows without you guys having to do all the downloads and without having to go through all of that. So I've package that up, and I'm gonna copy and paste it. So that's what's happening behind the scenes right now that you guys cannot see. Does it require a strong GPU? The training process for StyleTTS requires a pretty strong GPU, meaning that you need a lot of VRAM for it. However, the inference does not. So inference with StyleTTS is actually pretty fast on almost any device, CPU or GPU. It doesn't even require a GPU to get relatively fast inference for StyleTTS. But training wise, yeah, it's quite hefty. You might be able to hobble along with 8 GB of VRAM, but the issue with StyleTTS is that it just uses a lot. And so what's going to happen is if you try to train a model with that GPU, it's going to, on Windows at least, it's going to overflow onto your CPU and take forever to train. So wouldn't recommend it. Oh, 12 gigabytes. 12 gigabytes, you might be able to get away with it, but same thing what I said still applies. Alright, so just want to make sure that everything that I did here did not mess up, and I'm just gonna run the package real quick. So runtime python exe inference script, and I'm gonna copy actually a pertinent model that I need. So let's see. Let me create the model that I need here. Excuse me, guys. Mel. Place this into here. Put this configuration into here. I think that's all I need for this one at least. Oh, and then I need the data, the training data that I used, or the reference file. And then I'll slap that into data. Okay, so let's run this, try it out, and see if I don't run into any errors. If not, that's perfect. That's what I expect. But yeah. What version of StyleTTS? The one trained on the VTCK dataset or LJ1. It should support either one. I currently use the just the base one that they use with Hugging Face. There are some other models out there that you can play around with, and they do work decent for specific applications, but it would really depend on what your use case is. So yeah, there's that. All right, so that just finished. Let's see. Alright, so it's playing, but it's in the background, too quiet, but cool. It works, and yeah, we're gonna go with that. So let's just go and get some installations in here. Let's install Gradio. Yeah, I don't think that's gonna cut any issues. Have I heard of MetaVoice 1B? I have. It does sound good, and I was gonna play around with it a little bit, but haven't had quite the time to look more in depth or more in detail in it. So maybe sometime in the future. But StyleTTS2 is open source and for the most part quite permissible. So I figured that I would work with StyleTTS2 instead. Okay, so need to start getting things into a Gradio interface, or what do I call this? I'll call this web UI .py. Yeah, I'll have to check it out. I think the samples that I heard from it are pretty good, but yeah, haven't had the time to get to it. Shoot. Well, actually, for development, I don't want to be developing with a runtime package, so I will actually just go through and set this up inside of a virtual environment, because that's what I'm more used to. I don't want to give myself a handicap for trying to develop this. So I do have some notes on how I install StyleTTS. So what I'm going to do is Python 3.11 module virtual environment. Alrighty, and then yes, I am going to select that as the environment. And let me check requirements. I should be able to run pip install our requirements. And we should be able to get that going. I do think I should take out, at least for Windows, like these Torch audio stuff, because I want to reinstall Torch as the binary package that gets released. So I'm actually just gonna head over to the PyTorch page, go to the install section 12.1, copy this guy, and then go back into VS Code. StyleTTS is good, but it's not better than Tortoise. Well, it depends actually on what how you're grading it. StyleTTS is much more consistent, so it won't mess up on words, it won't have weird artifacts at the end of sentences, and it sounds really good. However, Tortoise still sounds more natural. So if you're looking for the utmost quality and you want to be able to, well, if you're looking for the best text to speech, it's going to be Tortoise or XTTS, because they're kind of the same thing. But if you want consistency, if you want stability, you want to go with a non-autoregressive system, which is like StyleTTS. So pip uninstall Torch, pip uninstall Torch, pip install, yes, paste this into here. Yeah, StyleTTS isn't as emotional. It can have emotion depending on what type of reference file that you pass it in. Reference file plays a huge role in StyleTTS, because it's got to create a style vector to inference off of. So what you could do, let's say you have a character, you could categorize it into 7 or however emotions you want, however many emotions you want, like angry, sad, happy, neutral, and then you could use those reference audios based on what type of style you want for a sentence. It kind of works. I haven't gone so far as to test that yet because I haven't had time yet, but I think that's the way it's described. Have I tried Have I tried a GPT Sovitz? I tried it in the beginning and it wasn't bad, but that was also when the interface was all broken. This was when it was initially getting released, and I haven't tried it again since then. So I'll probably have to go back and check it out. I know it's pretty high up on the leaderboards for Hugging Face, but I personally haven't checked it out. Alrighty. Phonemizer. Why don't I have Phonemizer into here? Phonemizer. Activate. Install Phonemizer. Hey, what's up, Tyler? Thank you for tuning in. Tortoise, well, I think it's case by case. Tortoise is still the best option if you want the best sounding audio and you aren't afraid to invest time into making or regenerating samples over and over. But StyleTTS2, it's very consistent. So I think, Tyler, you're running into some issues with your models where it's like repeating at the end. You don't get that with StyleTTS2. So, yeah, it's one thing. Like non-autoregressive systems are much more stable, and so I want to at least have one of those in the stack for things that I program with and use. Higher Speech TTS. I've never heard of Higher Speech TTS. There's a lot of stuff. There's a lot of text-to-speech engines out there, but they all give or take sound the same, maybe plus or minus 1% on how good they are compared to other models. So I haven't heard anything that's open source be revolutionary yet. I have heard some closed source models that are really good. Seed TTS from ByteDance, which is TikTok's parent company. They come out with a lot of good stuff. Seed TTS is really good. It's got emotion and laughter, and does it have laughter? But it's got emotion in it, but that one's all private, so we can't see that. Val E2 is actually coming out. And that is by Microsoft, so we'll see that open source pretty soon. 11 Labs still definitely leading. I think for Zero Shot, you can train XTTS and Tortoise models to sound better than 11 Labs, but I know 11 Labs also has a mode where you can create like a professional voice, and you can train it a little bit more. So I haven't tried that feature on 11 Labs. But alright. Where am I? Alright, so I just finished making my virtual environment for this code here. So now what I need to do is start getting the Gradio interface up and going. So Gradio, do that in there, import Gradio, and then let's see, I think it's gr blocks as demo. Oh, I'm gonna have to look at documentation. Okay, here we go. Does XTTS use hi-fi GAN as vocoder and the mail spectrogram is generated with VITs? XTTS does use hi-fi GAN as the vocoder. The mail spectrogram is created by the autoregressive model, so it's basically the same architecture as Tortoise TTS. I'm trying to remember. I don't know if it creates a mail spectrogram directly out of the Tortoise model. I think it creates tokens that are then I forget how the architecture is for Tortoise, but you know, the autoregressive model creates tokens, and then either the diffusion or the GAN part converts it into a mail spectrum, and then that mail spectrogram is turned into audio. I actually forgot. I haven't checked it out recently. Original Tortoise uses diffusion as the original method of processing the autoregressive outputs. What's up, Lion Ryan? Thank you for tuning in. How's the Japanese going? Are you kicking it along? Mine is not. Mine is sucking. Been playing too much Elden Ring and training these models on StyleTTS. Of course, Tyler. You know, it's. I figure out how to use these things, and you know, I've got a YouTube channel and just share it. So, figure if I find it useful, and others will also find it useful. So, I'm glad you enjoy it. JPDV finished. Not Jolzu. Dang. Neki Night. It's okay. Me too. That is okay. Alright. Hey, ramen is delicious. The drink. Haven't had ramen in a while because it's unfortunately is pricier than I would like. But yeah. You know what? I don't want to use. I'm not gonna read the documentation and go through it. So I'm actually just gonna use ChatGPT. So let me log in real quick. Because why not use ChatGPT while I can? Makes things faster. Yeah, why look at documentation when I can look at ChatGPT? Well, I can read documentation, so... But I can use ChatGPT to make my documentation reading skills or my documentation... Yeah, I can use ChatGPT to make my workflow much faster, so why not use it? Alrighty, here we go, ChatGPT, the GOAT. I might also have to play with Claude, because Claude, the new Sonnet model, is supposed to be pretty good. Real Callum plays. Can I ask what StyleTTS is? Can I ask what StyleTTS2 is? I'm gonna ask it 10 times. A quick summary would be appreciated. Of course, StyleTTS in the name, text-to-speech, is a text-to-speech engine that sounds pretty good. And I played a sample earlier, but I'll be maybe playing a little bit more later on. But yeah, it's just an advanced text-to-speech engine that utilizes machine learning to sound good. Do I use RVC at all? I will be using RVC after this, so yeah. Can you create me a quick Gradio interface with blocks? Alrighty, here we go. ChatGPT code, boom, done. Let's run this. Yeah, GTLOT 3.5 is supposed to be really good, and I haven't gotten to try it yet, but looking forward to it, hopefully. 7860, okay, localhost. Output text. Cool. Nice. Alrighty, so now I'm going to iterate on this. I'd like to create, let's say, 3 tabs that have different interfaces. One, let's see, the first named, I'll call it generation, the second named training, and then the third named settings. Can you modify this for that? Well, it is a 0-shot. It does have 0-shot enabled in it. You just give it a reference audio, and it can do that. But, yeah, they're all kind of the same. You can all train these deep learning models more. You can always train the base models to get them sounding closer to a voice. But it also does 0-shot. Tortoise also does 0-shot, but it's just not as good in my opinion. First voice will be cloning and saves. Ooh, sorry to hear about that, Tyler. My condolences. These, one thing about these text-to-speech systems is, it enables you to do things such as that. So people who want to utilize these deep learning models to accomplish those types of tasks, I think it is a great use case for these open source text-to-speech engines. Alrighty. So let's go ahead and run this and see what's going on here. Random person, do I know any web UI for XTTS? Because all of them try to work. Dasser's XTTS training GUI web UI kind of works, but you do need to modify some things. I ran into many issues with it, and I didn't particularly like it, so I never used it. I made a modification of it and got it working for my use case just to try it out, but I don't, the modifications I forgot, and I have not uploaded it to GitHub. Okay, so I've got a few options here, and not a few options. I got 3 tabs here, and now what I can start doing is building off of it. And so I'm going to go into my Inference Script here. And then see what needs to be done inside of the web UI for this. Utils. So ideally everything inside of this inference script, what I want to do is do the same thing inside of the web UI. So load configuration, set the device, model parameters, load models. I think I have already kind of refactored this code to put these things into functions. So I will just kind of go through this the same way. So Inference Script. I wonder if I could put these into like this utils Python file. Okay, so I'm gonna start moving these things into this. Okay, so what I'm currently doing right now, I have an inference script that works on the right hand side here, but in order to call it from my web UI, I'm going to need to import it or import these functions so that I can do all of the proper loading. So I don't want to import inference script. I just don't like that. So I'm putting it into the utilities Python script so that all the utilities that I need are inside of one location. Okay, and then I'm going to do the same stuff here. From models, import those. And I think I needed to import random. Import random. See if there's still any squigglies here. Global phonemizer. Okay, I'm missing phonemizer. Oh shoot. Ooh. Global phonemizer. Tokenize NLTK. Okay, that gets rid of those squigglies. However, it looks like I'm using a global variable inside of this inference script. And I need to check up on something real quick on how these how I can get the global variable working across different scripts. Let's see. So what I'm doing right now is I'm just opening up my AI voice cloning repository, the one that already has the graphical user interface built for Tortoise, and I'm going to be going through just some of that real quick in the background, just to check out how some of these things work. Okay. Alright, we'll have to see how that works. Use GPT-LOT, give it a shot. Oh yeah, definitely I'll have to use GitHub Copilot. It is GPT-4, so I mean I use 4 Omni. It's not too bad. And it generally gets most of the stuff that I need done. We use let's see. Have I used Piper TTS? I have not. I've heard that it's low resource though, so something I haven't gotten to though. Yeah, this will receive its own line of tutorials as well to go through the process. Yes, indeed. So I don't think I'll be able to set global variables inside of the utilities folder. So I just have to see where global phonemizer is being used. Inside of here, global, or yeah, global phonemizer. Okay, so it's only being used inside of inference. So what I can do is just turn this into a parameter that I'm going to pass into inference. Okay, add a comma here. And then I will create something called load phonemizer. And then, yeah, I guess I'll just, return global phonemizer. Okay. And then, yeah, I should be able to do that, and that should resolve my issue. Let's see. Any tips on creating voices that have a vocoder style? Tried training the AI voice coding repository and got close, but left your plain voice without those effects. Voice is GLaDOS Portal 2. Well, you can try training on more data. I'm not sure what you mean by vocoder style. But Tortoise is, and most of these text-to-speech systems are generally pretty good at generalizing to the voice that you train on. So if you're finding out that it's not sounding the way that you want it to, I would just train a little bit longer or train on more data. But it is kind of hard though, because the issue is that a lot of these pre-trained models didn't have like maybe some of the reverberations or sound of GLaDOS from Portal. So when you're training it, you're giving it a completely new feature, so to speak. And then it's got to learn off of that. What's the best TTS that besides Tortoise that works locally and has a web UI? XTTS, which is basically Tortoise. XTTS is really good. There are more inference web UIs out there that exist that allow it to be used. That would be, I think, one. StyleTTS is good, but I haven't found any web interfaces with it for it. Other than that, I can't really think of many. I mean, you have like GPT Sovitz, someone mentioned earlier, that has good outputs. And that one has a graphical user interface. So that is definitely one thing you could check out if you want to try that. Okay, so I've got that. I've got everything inside of the utilities function utilities module here. So now what I need to do is inside of the web UI, I need to start adding buttons and all of that stuff. Alrighty. Okay, so I could say choose speaker, and then what I would need inside of here is a say like a voices folder, kind of similar to the AI voice cloning repository. So I'm going to steal some functionality from that other interface because well, I like a lot of stuff from the AI voice cloning repository. So let me go into that. Let me hide this. Then hide this. Okay, so here we are inside of the AI voice cloning repository. I'm gonna scroll down to that feature that I want to take from it, which is instead of the web interface, and that is going to be this voices here, right here. Okay, so I'm going to take that. And then I forgot all of these are inside of a ginormous list. So is it a dictionary? Okay, no, it's a dictionary. Okay, generate settings. Then I need to steal voice list with defaults. So I'm gonna go into here and look for voice list with defaults. Which is this right here. Throw this in here, and then I need to take this function from the interface as well. Okay. So if I go into here, slap this into here, I have now a very large file. And actually, I'm going to place this inside of the utilities Python file. Okay. Ooh, and then I need this get voice directory. Tortoise utils audio. Sorry, I got tired of switching back and forth between the two, so you guys won't be able to see this. Let's see. Tortoise utils audio. Okay, get voice directory. That, get voice. Alright, that's the last thing I need to take. Ooh, and then I guess this is also, I guess this library is going to be licensed as GPL because I'm taking stuff from Tortoise AI voice cloning repository. Interesting. Will I ever complete Mushoku Tensei, the Ranobe? I don't know. I don't know if I'll finish Mushoku Tensei. At least the light novel. We'll see. We'll see. That's a lot of reading to do. Oh yeah, for sure. For sure, Real Callum plays. But, you know, 20 minutes should be able to get something decent. But you'll have to play around with some of the hyperparameters and training settings, and it's just going to be an iterative process. Yeah, Mushoku Tensei, GG. It's okay, I'll get back to it eventually, maybe once I start reading more, but we'll see. We'll see how that goes. Okay, get voice list. I can import that from utils import get voice list, right? And so that should work. Call that voices. All right, voice is with defaults, so this should work here. Output, say, I'll comment that out for now. I don't need that. Generate button, yeah, I'll leave generate. On click, generate text. Okay, so what I'm gonna do is create a function here called on click. Start generate audio, and then so this is going to be the main function that I use to generate audio, and then the inputs are going to be a lot. So let's see, inputs, outputs. Yeah, GG Mushoku Tensei. Eventually, when I get there. Oh, I do want to take a look at how it's implemented in the web UI for the onClick. Okay, so I'm going to need to turn these into lists. Generate settings. I'll just leave that there for now. Okay, cool. So let's go ahead and return voice. We'll return voice, and then I'm going to add a voice inside of here. Mel data. Throw in a data sample into here. Okay, so let's go ahead and run this web UI for now. See what we've got so far. Edge. Refresh. Alright, voice, cool. We can choose the voice. Mel, let's go ahead, generate. Gives me Mel. Cool. Cool. I got my voice. Text to speech has always been fun because you can actually hear a computer. You can hear it, you know. It's one of the, I don't know, like core fundamentals of conversation and just being able to interact with the real world, or at least with people in general, is through audio. Text speech allows us to interact with computers in a different medium, so it makes it a more enjoyable experience. And then you can change, you know, how text speech sounds, and it's just pretty cool. I like it too. Ooh. Voices list, defaults. I'm going to delete these defaults for this one at least. Don't need those. And then actually I can start formulating how I'm going to do some of this in my head. So now that I've kind of refreshed on some Gradio things, we can start getting this the generate audio working. So from this, I'm actually going to import all and generate audio. I can just simply start going through the Inference Script and then getting all the parameters and all the steps needed to get this going. So load configurations. Ideally, we'd want to set this in a way to where we can get the configuration for the voice that we want to inference on. And so now I'm going to need to start creating some specific StyleTTS2 functions. And yeah, so get model configuration. This does not need to take in any parameters. It's just going to return. Oh, actually, how do I want to? Okay, I will look for a root path, which is located at models, and then I will take in voice, and then I will pass in voice, and then I'll need to do a couple of more imports. Import OS, import, I think that's a import OS for now, and then for we'll go if os.path.join. You know, I'll do this inside of here. Voice model path equals os.path.join root path along with voice if model path, then load configuration. Let's take a look at some comments. Does it take random noise and try to make a spectrogram that looks like the target spectrogram it was trained on? Yes. As far as I know, that is kind of how that's kind of how Tortoise works. It diffuses a male spectrogram from the output of the autoregressive model, and then it uses a vocoder to convert that male spectrogram back into audio. Have I used character AI? I guess they have the voices of all the actors they're impersonating. Oh, really? I did not know they had the voices of the actors they're impersonating. I thought they were just chatbots on character AI. I have not used it that much, unfortunately. Or fortunately, depending on how you want to look at it. I've heard that it is very popular, though. I know for a fact that these chatbots are very popular. XTTS uses Hi-Fi GAN, and I'm trying to remember how exactly it works, but it goes autoregressive model, then it gets fed into Hi-Fi GAN, and then I think there is still a vocoder step after that to convert the male spectrogram from the Hi-Fi GAN model back into audio. Though I'd have to take a look at the inference process for that. I could be completely wrong. And then, so if model path exists, I'm going to for file in model path in os.lister of model path. With YAML. No, YAML, YML. How do I raise Gradio error? GR error, okay. Raise error. No configuration. Configuration for model specified located. Okay. Else, none. Okay. Yeah, I mean, I haven't done a deep dive breakdown or anything like that. I've looked through the code, and you can find out. The reason I like stepping through code so much is you can follow step by step on how these are done. So that would be my recommendation. Alright, so web UI. Let's see if my code is correct. Alrighty, mel here. Let's generate no such file or directory mel. Okay. Let me step through this, see what's going on. Oh. Hold on. Oh, oops. let me make sure I'm calling this get model configuration with the voice. All right, boom, and let's retry that. Alright, I probably gotta go in like 30 minutes. I'm gonna go cook some sausages and have some dinner, so we'll definitely not finish this in tonight's stream. Maybe I'll stream afterwards. It'll be a late night stream. But we'll see. Alright. Now, generate models. Alright, let's step through the code. This is why I like stepping through code. It's awesome. If model path, here is model path. Alright. File ends with YAML. Configuration path is the YAML folder. Okay, if not, nice. Huh. Oh. Let me do configuration path equals none, and then see model else gr error no model located in models folder. No model located in models folder. Alrighty, cool. So this should work. Alrighty, edge. Let's go ahead and run through this. Okay. Alright, configuration path equals that now. I set it to none. For file in OS list directory. For file in OS that for file in OS if file that ends with I'm definitely doing this wrong. If model path for file in can I say else pass? Oh wait, hold on. If file ends with YAML, store configuration path equals file. Okay, that should work. Okay, cool. YAML load. It's not loading YAML. Okay, it's getting a none. What did I get there? So we run this. Okay. Right, let's step to the code. Okay. Cool. And then what I need to do is return configuration path. Nice. I should be able to do this. Okay. Cool. Perfect. os.path dot join of model path with file. Cool. So with that, the configuration file should now successfully load, and we should be good to go. Alrighty. Awesome. So this works. It's not giving me any errors. So configuration has been loaded. That's great. Now, this device can also be set globally. So device equals CUDA if torch.CUDA is available. Import torch. Alrighty, and then I'm gonna need a custom function for this model equals load model. I'm gonna call this load voice model, and then I have to specify the voice. And then what's gonna happen is it's going to, I need to create a new function for this. So define load voice model. I'm gonna take in voice, and then you do the same checks here. I could use this for the I might be able to use the same function call maybe. Yeah, this is exactly the same thing, so what does StyleTTS use for generating speech? it uses an inference reference file, and then it uses a PyTorch model that you train or pre-trained file. And it also uses some other things like phonemizer. It converts text into phonemes using eSpeak phonemizer. And I think that's it. Alright, so let's generate this. No configuration for oops. Alright, let's do this. Let's rerun that. Okay. Cool. Prints out the configuration and it prints out the PTH file that I need. Alright. So there is a overlap between these two. And I am going to get the opinion of ChatGPT on how to optimize this to make it more modular. So let's do that. Let's go into here and let's create a new chat. I have some Python script I'd like to make more compact. Could you make this more modular? Okay. There you go. I like that. So this is one thing I love using ChatGPT for, is I'll write something that is super inefficient, and just kind of get the concept out, and then I'll ask ChatGPT to refactor it. So cool. So it took the common parts that I needed, put it into a get file path function, and then created specific functions for each call. So hey Lokesh, thank you for tuning in. Welcome back. I wonder if file extension and error message. This is just to make it more explicit for myself. Don't actually need those. Voice equals voice. Voice equals voice, and then root path equals that. Okay, cool. So that worked. Now let's move on to the next part, which is load models. Model path. Model params, load models. Okay, so these are the other models that I need to load. Load params, configuration, and device. So I do not want to specify the location of these models inside of configuration. And so what I mean by that is inside of each configuration file, you have all of these locations to specific paths for specific models. So what I want to do is I want to take all that out and be able to hard code that somewhere. I guess I'll start by hard coding that into here. So let's go into load models. Let's double click into it. And then I'm going to pass in hold on, I want to see where else this dot config gets used. See if I actually need it for anything. I'm just gonna manually specify all of these things, and I don't need this configuration file. Okay, config. Oh, okay, it's not used anywhere else other than this load models function call. So, oh, there goes my camera. Camera's gone. Let me put a new battery in. Sorry, just... Oh, I am still not on. Alright, I am back. Can I make a tutorial on how to convert a Python project into one-click app or something that automatically installs dependencies and runs? Maybe, but yeah, we'll see. There is an easy way to do it with PyInstaller. However, I find that PyInstaller sometimes doesn't work for more complicated things. Okay, so I just got through here and noticed that I probably don't need it because I want to try to load everything independent of the configuration file. So yeah, so what I can actually do is just, I guess, create a default configuration for all the model paths. Okay, I think I know what I want to do. I'm gonna copy this, go into models. We're gonna create a model paths.yaml. And then I'm going to load models. Web UI, and then I'm going to create a new function called load models web UI. Put that inside of utils. Throw this in here. Or actually, what I'll do is I'll build it inside of the script first, and then I'll move it into there afterwards. So define this, and I'm going to call configuration path by default is equivalent to capital models / model paths.yaml. So hard code that guy into there. And then I'm gonna copy all these into here. ASR configuration is equivalent to I want to turn this into something that looks nice. So I'm actually just gonna ask ChatGPT if he can give me a script that'll turn this into something that's more nicely readable. Give me a Python script that will make this YAML file more readable. Okay, and then so just going to create a quick convert YAML.python file so that I can format this YAML in a more readable way. Well, it looks like it just gave it to me, so. Okay, cool. Go like this, paste this. Python debugger, YAML, formatted YAML. Throw this into models. Delete this convert YAML thing. Go into here. Call this model paths. All right. And I can now start messing with some things. Okay, model paths.yaml, ASR configuration, config ASR configuration. All right. ASR path gets that. Load ASR models. That's fine by me. F0 path, okay. So models, that's fine by me. Bert. Okay, gets Bert. Load Bert. As much config model params. Okay. Build model with model params, text builds all of those. Okay, the only thing I need in here to be editable is this Sigma data, and I want to pull that from the configuration file. Print model params. Okay, let me stop the code here. Let me run it. BERT. What is a BERT? BERT is an autoregressive model that is I forget. But it's used in a lot of text-to-speech training, and I think it's for feature extraction. Hubert is hidden unit Bert, and Bert is Bert. Yeah, I can't pull off the exact. Bert. Bidirectional encoder representations from transformers. So that's what it stands for. And so you'll have to do some more reading on it. I can't give you a good definition off the top of my head right now. But it's used to train models for bidirectional context, so it knows what's coming before and what's coming after. And I think it's used for like masked training. So you mask a portion of a training sample, and then you predict what that masked portion is. But yeah, you'd have to read up on that. Unfortunately, I can't give you a cohesive explanation of it. Okay, print out model parameters. Munch. Okay, so the only parameter that I want to be able to adjust from the configuration file is the what was that? I just pulled a blank. Sigma data. Okay, so for this, I'm going to look inside of here. Sigma data. And ask ChatGPT. Inside of this output, how would I modify Sigma data or something custom? Open source trainable sound effect generators. You'd probably be looking at Facebook's VoiceBox, I think is what it's called. VoiceBox Meta. Yeah, I think it's Meta's VoiceBox, but it's not a simple thing to train, unfortunately. Okay, so what I can do here is, let's say, model diffusion dist sigma custom value equals 5. Let's do, and then let's print out model. Make sure I've got that customization done correctly. And hide edge. Alrighty, let's get that running. Let's generate audio diffusion. Okay, audio diffusion conditional. Let's see. Model dot. Okay, hold on. I have to go model dot diffusion hurts my brain. Let me try this in a different. Let's say I have this output here. How would I perform the modification correctly in my code? That's why I didn't ChatGPT. What other open source AI do I use or like? I'd say all of them. I like all of them. Llama is great. Stable Diffusion is awesome. And text to speech. I do text to speech, so I think it's pretty cool. Model diffusion dist sigma data equals 5. Assumes that. Okay, that is what I did, and then I get this error. Oh, I have this set in the wrong spot, I think. Model params, okay. Yeah. I think I have this in the wrong spot. Print model params. Okay, let's try that one more time. I actually haven't tried Stable Diffusion 3. I've heard that there's some controversy around it. It's like becoming a little bit more commercialized. But what do you expect? It's impossible to compete if you don't commercialize your product somehow. I wouldn't say impossible, but it's just harder. But I mean, Stable Diffusion, XL and all the other ones like 1.5 are still popping off. There's a lot of improvements that have been made in that area, I think. Okay, Sigma data, cool. Alright, I got my Sigma datas done here, cool. Oh yeah, TTS AI, definitely, me too. Been hooked for a while. DALL-E 3 definitely leads, but not open source. Okay. But alright, what am I doing? Okay. So a couple last lines of code that I'm gonna do before I end the stream, because I gotta go pretty soon. Is I want to modify it to where I can grab the Sigma data here. And so inside of configuration, I think I'm going to print out config here. So let's go ahead and do this. Alrighty. Okay, print out the configuration. So I'm going to pass in a sigma value. I'm going to set this equal to, well, now I'm going to make it a mandatory pass in sigma value. I'm going to call this sigma value is equal to, I'm going to pass in sigma value, sigma value Sigma values equal to config dot. All right. This is a dictionary, so I have to access it with dots. All right, ASR. I think I might be able to access it the same way that I do inside of here. Let's see. Print sigma value. Sigma value. Has no attribute diffusion. Okay. Yeah, Tortoise, I love Tortoise too, which is why I've put so much work into Tortoise. But yeah, it's not consistent enough for production. Like, you can train a model to where it outputs it correctly like 95% of the time, but other than that, it's really hard. Okay, data params. Okay, there's one curly bracket here. Okay, it ends there. Price, loss parameters. Okay, I think this is it. So I need to access config dot loss params model params. I think this is it. Well, currently what I'm not really running into any errors. I'm just running into like YAML dictionary structures that I just need to figure out how to access data from. And I'm being stubborn and not throwing it into ChatGPT for how I would access the value that I want to access. Estimate sigma data. Dict object has no attribute loss params. Okay, maybe it's model params. Model params. StyleTTS is definitely good enough for audiobooks, which is why I'm putting work into it. I think StyleTTS is pretty good. Oh yeah, absolutely. We'll look forward to it. I'll be putting a lot of work into it, so hopefully it's worth it by the end of this. Ah, you piece of garbage. I'm just gonna stick it into ChatGPT and figure out how to how do I access it? No, just stupid. Just give me the output. Please just give me the Python variable. Not an entire implementation. Ah. Okay. Brain has been refreshed. Instead of dots, you gotta use the actual names for it. Okay. Sigma value. My bad. Okay, cool. Sigma data, pass in the sigma value. Sigma value is here. Sigma value is going to be used here. Sigma value. Okay, don't need that. But yes, this now does all of these stuff that I need it to. So I'm going to go into here, model params. Hey, what's up, Beds Gadgets? Thank you for tuning in. No problem. It'd be possible to change languages, train other languages in StyleTTS2. It is definitely possible, but you need to use a BERT model that is trained on that specific language. So I haven't done a deep dive into StyleTTS for other languages yet, but you can expect that it is in the pipeline for that. 100%. Okay. And there is a phonemizer. If ChatGPT lived in my house, that would be crazy. That would be a little crazy. Def load phonemizer, I'm gonna call that. Load. Or I'm gonna call this phonemizer. I'm just gonna keep the name global phonemizer. Load phonemizer. And I don't think I need. Yeah, it just returns it. Okay, cool, perfect. And then create sampler. I'll specify this later once I get this going. Hey, thank you for the super best gadgets. I very much appreciate it. Yeah, hope to get this all packaged up and ready to use. Well, realistically, ready to use by the end of July or mid-July. My work on these things takes quite a bit of time sometimes. Oops. Let me import time. Import time. Okay. For alrighty, and we can do this, and then instead of model 1, what I can do is model path. Call model path here. Load pre-trained model with all this, compute style, inference. And then for inference, I need to now pass in global phonemizer before alpha. Global phonemizer equals global phonemizer. And cool. I should be able to done. Put an input there. I actually don't know if I can do an input, and this is inside of Gradio. Let me see. Okay, generate. Go ahead and load. Go ahead and run. Alright, everything has loaded. Done. Cool. Alrighty. Testing some stuff here. So I'm going to I'm going to remove this input line here and turn off the music. Okay, generate some audio. Get everything all loaded up here. CUDA. Alright, it's taking a little bit of time to generate. What is going on here? Weird. Alright, let's rerun this, and maybe something odd happened there. Refresh this guy. Okay, let's go ahead and generate. Alright, and the code has finished. It has outputted the synthesis. Let's go ahead and remove this. And
Testing some stuff here.
okay, cool. So that works. Alright. So that's actually going to be pretty much all the functionality that I'm going to be able to code in today's live stream. But I have all of the stuff that I need. Now I just need to start putting some variables on Gradio so that they can be modified. And yeah, it's going to be a work in progress, but we're going to get a graphical user interface up for StyleTTS soon. And yeah, that's going to be pretty much it for today's live stream though. So if you tuned in, very much appreciate it. And yeah, I hope to live stream more of this, but we'll see how that goes. But yeah, that's going to be pretty much it for today, and I will see all of you guys later.